A warm welcome to you all for this today's online lecture. Today we are going to discuss about divide and conquer methodology from the subject of design and analysis of algorithm. Myself Sherin Glory, Assistant Professor from Department of Computer Science and Engineering, RMD Engineering College, is going to explain you about this concept. Now, what do you mean by this divide and conquer methodology? So whenever we have been already in this subject, we have already discussed about lot of methodology to solve a problem. So one of the predominantly used methodology is divide and conquer methodology. So what do you mean by this divide and conquer? The name itself says divide and conquer. What we are going to divide and what we are going to conquer. So whenever a problem has been given, the problem will be divided into number of smaller sub-problems of same type. Okay, then we are going to solve each and every smaller sub-problems. We are going to consider each and every smaller sub-problems as individual problem, and then we are going to find the solution for that problem, and finally we are going to combine it. So dividing and conquering and then combining, these are the three processes that is involved in this divide and conquer methodology. So a large problem will be divided into sequence of subproblems, and then these sequence of subproblems will be solved individually, and then it will be combined together. Okay, so now that has been depicted clearly in this picture. So problem, it has been given, and it is divided into subproblems, and then for each subproblem I am finding out a solution, and finally it is combined together. So again a clarity of uh, number of subproblems. A problem has been divided into n number of subproblems, so that has been given. So this is an easy methodology to find out a solution for any problem. So for this, what we are going to do is, we are going to see an example under this divide and conquer methodology. What is the example I have taken is binary search. What do you mean by this binary search? It is analogous to your binary search tree. So the concept is, all the elements to the left will be less than the root, and all the elements to the right will be greater than the root. So it will be in a sorted form. So in a sorted form of array of elements, I am going to find out an element using the position of an element using a binary search. So what is algorithm for this binary search has been given. Initially, I am initializing the low value as 0 and high value as n minus 1. Though this indicates the start of an array and end of an array. Until the low value less than or equal to I am going to repeat the sum process. What are all the process I am going to repeat? Until low value is less than or equal to high, I can repeat this process, that is mid is equal to low plus high minus low divided by 2. After finding the mid value, I am going to check whether the given searching key value is equal to the array of the mid element or not. If it is so, I am going to return the mid element as the position. If not, I have to check in another condition whether the given searching element is less than the mid element. If I found to be less than mid element, then it means it is definitely going to lie in the left side of my array. So I have to rename or reinitialize my high value as mid minus 1. If it is not less than a of mid, means it is going to lie in the right side of my array. So I have to proceed my search towards the right side. So I need to initialize my low value as mid plus 1. So this is the procedure I am going to follow in my divide and conquer methodology. Okay, sorry, using your binary search. So we have taken an example of this binary search algorithm. So all these algorithms, whatever I have shown you, are numerous way of using the algorithm. Now I have taken a list, okay, which I'm going to search the element 57. So first value is, first I have to calculate my mid value. So the upper bound and lower bound value is 0 and 9. So 0 plus 9 divided by 2 will give me the mid value. Okay, so first task is to find out my mid value. So 0 plus 9 divided by 2, it will come around 4.5. So I can take either 4 or 5 as per my wish as my mid element. Here I am taking 4 as my mid element. So I am checking whether A of 4 is equal to 57. No, it is not equal to 57. So next what I have to check, I have to A of 4 is less than 57 or greater than 57. So I found that A of 4 is less than 57. So it means it is going to lie in the right side. So I have to reinitialize my minimum value as mid plus 1. So then my new min value will be 5 and it is maximum value is 9. So 5 plus 9 divided by 2 is 7. So again I am checking with my mid value is compared. A of 7 is compared with 57. No, it is not equal to. So I have to check whether this 25 is less than 57 or greater than 57. I found that this 25 is less than 57. So it means this 57 lies in the right side. So again my mid value will be reinitialized as mid plus 1. So it is 8 plus 9 by 2. So it is 17 by 2 is 8.5. So I am taking as 8. So now my mid value is 8. So A of 8 I have to check. So the search value is equal to A of mid. So hence it is equal to A of mid. So I am going to return my current mid value. So this is how I am going to search in any element using my binary search. This is a typical example of my binary search. So what I am doing is whenever a problem has been given, I have divided into sub problems and then I am solving it. So when I am saying that, when I am talking about this analysis of binary search, it means I am dividing my sub problems into two sub problems of same size, that is of n by 2. So to calculate the what is the best case for this binary search is big O of 1 and worst case is log 2 of n, because we know n is nothing but the size of my array. So the number of comparisons, it always depends on the uh, number of elements in my array. Why I am saying this best case is equal to O of 1 means, say for example the very first mid element itself I found out the searching key means, so the very first mid element itself is giving me value. So number of operation taking place is only 1. So the best case is only best case is said to be big O of 1. So worst case is what is the maximum number of possibilities I am going to try to find out elements. So since there is n number of elements in my array, I can say it may take log 2 of n operations. So it is log 2 of n. And average case is also same as my worst case. So that's all about my binary search tree algorithm. Thank you.